Hello and welcome to Adafruit Show and Tell. We are live. Hello, I'm Noah Ruiz, designer here at Adafruit. Joining me this week is my brother Pedro. Hello.
Hey everybody, this is Adafruit Show and Tell. This is the best place to show off your awesome DIY electronics project, or it can either be printed, or it could just be like a tour of your cool workshop. So if you guys want to join in, go ahead and get the link over at discord.gg/Adafruit. We got a link posted in there, and I just tried posting it on the chat here, so it should be on there as well. It's a StreamYard link you can click on and join in. We're going to start off with a couple of the Adafruit folks, and then we're going to go over into the community. Let's go ahead and start it off with Trevor.
Yep. Hey, Trev.
Oh, hey.
What's up?
Oh, let me get your microphone. I think I can unmute you, right?
No. I got it.
Oh, you got it.
You go.
Yeah. How's it going, y'all?
It's good.
Good. How you doing?
Good. I'm pretty good. Here to show off this new update to our game. The Great Search. It's here. Yeah. So this is the game that we've been working on. It's called The Great Search. It's pretty awesome. Right here, this is our first level.
Wow.
Yeah, and you're kind of tasked to eliminate like the blue smoke monsters that's littered throughout the game. And you also, like, in this level, you're like making your way to the Adafruit factory, which is pretty cool. So this game is basically made to educate users on different electronics that we have. And I think level 2, you're able to kind of like collect like a Sega Playground Blue Fruits and an RP2040 and a BME 280, and it'll tell you like about the different devices and whatnot, and also tell you like a couple of like cool like electronic facts and whatnot. Yeah, this is the game. It looks kind of smooth. I like it.
Yeah, it's very fun.
Amazing. Wow. Yeah. I showed Gavin just a screenshot of it, and he was already excited to play it. So
awesome.
Nice.
You got a fan ready.
Awesome.
Yeah, I love the pixel art look.
Yes.
Bruce did an amazing job. Oh my gosh.
Yeah. Oh yeah.
And then we got music from Dan Q. That sounds super retro gamey.
That's right.
This is going to be amazing. And I don't know if we're allowed to say what else is going to be in the game, but
not yet.
I'm not going to. I won't spoil it, but definitely going to be some awesome rewards.
Oh yeah,
leave it at that.
definitely. Yeah. So this is what we have going on, and more to come.
Cool.
So this is going to be iOS.
This is going to be for iOS, Android, probably Switch, all the platforms. Hopefully. But yeah.
Hopefully, compatible with Switch 1 and 2, right? I hope.
Oh yeah. Oh yeah, that's right. Switch 2.
I don't know. Every time I see a new one, then Gavin's like, "Oh man, it's only for the 2."
Yeah, but coming soon.
Cool. I'm excited.
Yeah.
All right.
Thank you.
Sweet. Good work.
Amazing.
All right. We'll see more. All right. Have a good night.
See ya.
All right. Bye.
Just wanted to leave that video kept running. It looks so cool.
Yeah, it's very fun. We got a little early access, so we've been playing it. All right, next up, let's check in with Scott. Tanut. Hello.
Hello, Noah and Pedro. Thanks for hosting.
Of course.
Happy to be here. Probably my last show and tell for a while, because I'm going into full-time dad mode for a little bit here.
Cool.
For the latter half of the year or so. So I'm running it out with a chart. So last show and tell I talked about how I had found this optimization for garbage collection times. So if you've ever done CircuitPython and you've noticed that it like stops for a little bit, right? Like it doesn't run your code kind of like continuously. That's often where you've hit a memory bound, and it's in order to find free space, it's got to go do this like housekeeping process of figuring out what memory you're still using and what memory it can free up. And I realized when doing the Fruit Jam that we were doing a lot of bitmaps and a lot of sound buffers, and those sound buffers were making that collection process really slow. And I talked about this last week too, but by adding the ability to exempt allocations like that from this collection process, we can actually like really speed up the garbage collection time, because we don't have to scan those memory regions. So I did this quick test here. This is CircuitPython code. we're collecting explicitly, and I'm just using time monotonic nanoseconds to measure how long that collection takes. And what I'm doing is I'm allocating a new byte array every time around the loop. So CircuitPython runs and runs and runs and basically fills up memory and then crashes because it runs out of memory. But the question is, like, how long does that collection process take after doing every byte array allocation? And with this new stuff, byte array, the contents of the array itself are not scanned anymore. And so there's this other setting also. So the red line here is kind of what current CircuitPython would do. And the x-axis here is how many bytes have you allocated. So this is on a fruit jam with 8 megabytes of RAM, 8.5 megabytes of RAM. So we hit this about 8,000 mark before we crash. And you can see that as you fill up memory, your collection times get much, much longer. This is 18 seconds here. It's really slow. And we don't do a lot of things. We don't do the display. We don't fill audio buffers and things when we're doing garbage collection because we want to make sure we don't miss anything. And then the MicroPython people, we met with them. They gave us this pointer on, there's a stack. So basically how many things do you still have to look at? And if you hit that point where you can't remember all the things you have to look at, you kind of have to start over. So this yellow line is if we set that higher so that we don't have to kind of start over during that process. And then this blue line that you can barely see leave the x-axis is after we do this, what I call selective collection. So you've allocated a byte array, but you don't have to scan it to look to see if it refers to other things. And it's just like significantly faster. For this like worst case scenario where all of your memory is this like raw data instead of other Python objects. So I thought it was really interesting. Lamore had said, hey, before you go on full-time dad mode, you should at least write a demo that shows the problem, which is what this is. And then as I was doing that, I was like, I got to make a chart. And then I was like, oh, if I make a chart, I got to make a blog post. And so there's lots of words up here if people want to know more about this. But I just thought it was kind of a neat thing. And another point is that like the MicroPython developers, like Damien gave us this pointer to this other optimization that's included in this testing. And then this is a great example of like an optimization or a changeable try in CircuitPython that they could totally take and put into upstream as well. Because MicroPython should be able to benefit from this too. There is a bit of a cost because you're storing a little bit more metadata about every allocation, but it's really not that much. And the speed up is kind of huge if you're in that zone.
Yeah, you can see it there. Wow.
Yeah, pretty excited about that. It's currently only an absolute newest, but the next 10 alpha release that you see come out will have it as well. So people should check this out. This is on the Adafruit blog here.
Awesome.
Cool.
Exciting.
All right.
Yeah, thanks for sharing. I'm sure,
thank you.
Hopefully
Thanks for
they pick it up.
Yeah, I'm curious to see like in real world if people notice a difference. I certainly did when I was doing like some Fruit Jam demo tests for sure. Like the audio glitches are like a lot shorter and you don't hitch as much. So yeah, I'm looking forward to it.
Awesome.
Cool.
Thanks so much. And
All right, folks, be on the lookout for that release.
Yeah, thank you.
All right, have a good one. Cool. All right, next up we have John Park.
John,
Hello.
hey.
Let me bring in your camera here.
Right on. Yeah, thank you.
So we have
showing off a little prototype arcade of my computer space arcade cabinets that I've been building and printing here. And I finally have the working one here. This is actually just a camera trick. These are the same size here.
Okay.
Oh, okay. I was like, oh my gosh, that
earlier iteration. This one actually is small. Put these over here, but the idea here is that I've modeled a cabinet that was the first video game in the arcades, which was called Computer Space, and it was made from it was designed in clay originally, and then a mold was built, and it was made from fiberglass, kind of like how hot tubs and boats of the era were made. And so it's got this great swoopy design, which you never really saw again in an arcade for the most part. I've got a little feather on a feather doubler here that I'm using mostly just to make wiring nice for me. So I've got a little sort of cable bundle here going up to an OLED display, one of these graphical OLED displays. So I can just plug that in, and also have a little battery on there so I can run this in sort of demo mode. So if I turn that on, you'll see I've masked off my little screen there to this is not the greatest camera in the world, sorry, but I've got the screen there. You can sort of see it's inside of a little masking bezel that gives us this nice ratio here. That's nice. What it's doing there. So it looks a little more like a TV because this OLED is more of a widescreen. And it's just running a little attract loop, like a little demo thing. I'm not trying to play the game. This is just a little decal that I stuck here to look like the game controls. For three reasons. It's not a fun game to play for the most part. It's historically notable, but it's a much less satisfying version of something like Asteroids, which is probably what you'd rather be playing. And it's also just so tiny. And it was a lot easier to code just as a demo rather than trying to do interactions with it. So I just have it sort of playing the game there. There's these two UFOs that are your enemies. They shoot at you, you shoot at them. Hopefully we win and no one cries. So that's the finished thing there. I've printed it out in kind of a nice glittery PLA here. It was made in four colors. There was a glittery red, which is pretty similar to this stuff. The yellow was not glittery, but I wanted glittery. And there was a glittery blue. And then they also made, I think, there was one cabinet made that was pure white, and it was a prototype, and it was maybe brought to some trade shows. And apparently it appears in Soylent Green, I think, in one scene in an apartment. It's in the background there just because it's so sort of retro-futuristic looking. The set designers got it brought in to have someone playing it in the background. So Learn Guide, I just finished writing that up. It's in moderation and hopefully will come out soon for anyone who wants to 3D print. It just prints pretty much in one piece like this with some supports on the bottom. And I also printed out that little bezel there, although you could make that out of cardboard or something if you feel like it. But that is my little desktop arcade.
Super cool. Yeah.
And one thing I want to look into that I'm meaning to ask you guys about is adaptive layer height, because I've got these flat regions here that end up, I think I'm at 0.2 layer height for this whole thing right now. So I was thinking maybe telling my print to get a little finer there to reduce a little bit of that sort of topographical.
Yeah, I would totally fill it in.
Okay. Yeah, I'll give that a shot.
I would do 0.1, I think, when it gets that area. That's just give it out.
See how that does. Yeah.
Cool.
Or even just printing it. Looks like it could print completely vertically, like the way you have it standing right there.
Yeah, I haven't tried it that way, and I think you're right. It definitely could print that way. I think I might then get some of that stuff up on the top here. So
Yep.
I'm not sure if there is an optimal, maybe like on a weird angle or something like that would be really good.
Yeah.
But, yeah, people want to experiment with that, and let me know what's your favorite way. I should probably make a smaller scale one for those tests, but I don't know.
Yeah.
You're using the tree supports, right?
I am. Yeah. There were tree supports just in here.
Good, huh?
Yeah, it worked well.
I've been so surprised on printing just completely 90-degree flat things and just how well the tree supports work on it. I've tried with just regular zigzags and it looked like crap. So
yeah, and they're so much faster because there's so much less to print. Yeah, this is on a Bamboo X1C that I'm printing on, which is a joy to print on. So
yeah, excellent. All right, we'll be looking forward to the guide.
Right on. Thanks, guys.
Yeah, we'll see you tomorrow.
See you tomorrow on the workshop.
Cool. Sweet. All right, see you then.
Thanks, John.
All right, bye. All right, that is all the Adafruit folks. We have some community members that we're going to jump into next. Starting off with, I think you're going to play us out too. We got T-Rex. Hello, sir. How are you?
Hey.
Hi, I'm doing well.
Excellent.
So I'm working on a special needs adaptive board.
Oh,
okay.
There's a young girl who has basically 8 basic needs, but she's dissociative.
No.
So let's see if
No.
we got that.
Cool.
I've tried to make very interactive buttons. Apparently I don't know how to operate this camera. There we go.
No.
That's great.
All the buttons vibrate.
Oh, wow.
Light up. It says the action that she's looking for in Thai, which is her native environment. And then there's an color LCD screen that I don't have the graphics for, but it'll have a full menu system.
Sweet.
And it's based on a Feather 2350 with the Class D amplifier and a whole lot of 3D printing.
Nice.
Ooh. Nice
So
enclosure
cool.
design.
Yeah.
And then, yeah, everything is very strong. The one she'll be getting will be very colorful. And hopefully I'll be getting that off in a couple weeks.
Super cool. And
That's fantastic.
yeah.
Thank you. And then my goal is to, after I've solved the need that actually exists, to turn it into a speech board to say anything like I did back in the 90s.
Very cool.
Excellent.
And the board that we saw on there, is that custom or is that off the shelf?
Yeah, those are just custom button boards and interconnects.
Wow.
I'd ordered a latch because I wanted it to be able to put the Feather to sleep to save power. The latch didn't work, so I just threw a TI 430 in to act as a ultra low power latch and put it back together. And I think I could get the BOM down to about $20, quantity 10.
Huh.
Nice.
But ultimately, these are all very individualized to the person. So the buttons are separated and the buttons will vary on the target, the capabilities of the special needs person.
Yeah. I see. Is it a rotary encoder up there by the screen?
Yeah, I just love them. And because she's not doing good associations at this point, there's going to be pictures of each of the needs on top of the buttons, but the rotary encoder will also go through the icons.
Okay.
And if she pushes the button on the rotary encoder, it will activate the corresponding button. And the hope is to try and build some associations as well as make it easier for her her helpers to provide her needs.
Yeah.
Very cool.
Cool. Well, thanks for sharing that. That's very cool.
My pleasure.
All right.
Thanks so much.
All right. You have a good one.
You too.
Thanks.
All right. Bye. All right. And that's going to do it for this week's show and tell. Thank you, everybody, so much for participating. And don't go anywhere. At just a couple more minutes at 8 o'clock p.m. Eastern Time, Ask an Engineer is coming on. We'll see you next week, folks. All right. Bye, everybody.